So I'm Duncan Moore. I'm Director of Product Management for Object Storage at NetApp. I've been with NetApp about 18 years now. I'm out of our Research Triangle Park facility out in North Carolina. And I'm going to talk to you about StorageGRID Webscale, which my boss hates when I say this, but it's the best kept secret at NetApp. This is our object storage platform. What I'm going to do is give you my view on where this industry is going, some of the trends in object storage, the verticals that we see it coming into play and why. And then we're going to dive into the product. We're going to start kind of 20,000 feet and then go straight into the weeds. So let's go. So if you've listened to pitches from storage folks over the years, you have undoubtedly seen millions of slides that say things like, unstructured data growth is out of control, right? And that's nothing new.
Never heard that before.
Yeah, exactly. What's new, though, is in some of these workloads, it's not just out of control, it's to the point that it's breaking things. So there's workloads now that just cannot function with traditional file approaches. So, Internet of Things. In the case of what I've got some experience with is major manufacturing, automotive, the sensor data that's coming off of cars, massive amounts of data needing rich metadata, needing to be shared across sites. This is a very difficult problem to solve with traditional file approaches. We see object going in there. Anything to do with rich media, rich content. And to me, that translates to usually large things, and large things that benefit from lots of metadata. So in the fields of energy, we're talking about seismic data. In media and entertainment, we're talking about the massive media asset archives and the MAM systems that manage them. In life sciences, we're talking about genomic research and these massive repositories that need to be shared across researchers. These are just some of the examples that we're seeing movement by the ISVs in these spaces to adopt object APIs. We're going to talk about some of the challenges. How do you get from here to there? If you're a greenfield deployment, it's easy to say, oh, I'm just going to start with object. A lot of these folks have billions of files now. How do they get there? So we'll talk a little bit about that. So I categorize the areas that we've been focusing on the last couple of years in three broad categories: archives, media repositories, web data repositories. And the reasoning behind this, archives, why? And this is archive as a service, backup as a service. This one is easy, why this moved to object quickly. It's because all of the ISVs in this space were the first people to adopt, S3 APIs, right? So things like SemanticNet Backup and Commvault Sympana, and virtually every one of the major backup vendors is now supplying some form of cloud connector that allows you to connect either on-prem or to an object store in the cloud somewhere. So the ISVs led there. Media repositories, similarly, we've seen a lot of the MAM vendors and media asset managers moving to adopt object stores. So the peoples like Deled and PrimeStream and Signient and Aspera for acceleration, all of these folks now support object. And I'm going to close at the end with a slide that has just a big splash of logos of the partners that we've already certified with object. But I have a person on my team that his full-time job is helping give access and credentials to our public endpoints for certification and testing and so on. So we're constantly adding new ISVs. The last one is web data repositories, and you can think of this as the born in the cloud kind of applications anyway, right? These never were files. They started out as objects, right? So I speak at a lot of the universities around RTP to their grad engineering schools as part of our outreach. And I went there with one of our SAN architects a couple weeks ago to NC State, and I said, these guys know everything about object, and they know nothing about what you're doing with block and SAN. And he's, no. SAN is way bigger in the market. I said, yeah, but this is education. It's different. So we went in the room and we said, how many of you have developed applications using SCSI type block protocols? No hands go up, right? How many of you have written applications using traditional file interfaces in file systems like NFS or CIFS or SMB? A smattering of hands. How many of you written disconnected applications using mobile apps, using RESTful data management APIs, everybody in the room. So one of my messages when I go meet with customers is to say, if you're hiring a lot of graduates, this is going to be the least resistive way to move in application development in the future as well, just because this is what the folks are learning. All right, so a little bit about StorageGRID. I want to get across that StorageGRID Webscale is not a 1.0 product. In fact, it is the longest life cycle in the enterprise of an object store system out there. So we bought a company called Bycast back in 2010. We've developed and iterated on that architecture over the last 7 years. We're currently at our version 10.3. A new release is imminent. Just to give you an idea, we're iterating fairly quickly. We made significant investment in the product line in late 2013. Since then, we've been doing releases on a 6-month cadence. So it's a 100% agile development team spread between RTP in North Carolina and Vancouver, British Columbia, where the acquisition took place. So a lot of innovation happening there. We're able to add a lot of capabilities very quickly. So let's get into the product itself. So this is an old version of the data fabric slide. And my point here is to say, the data fabric really has a couple of lanes on that freeway. One of the lanes is the SnapMirror protocol. The other lane is S3. And what you see since the last time you heard about the data fabric and since Arthur came up here again is that a lot of the innovation that's happened has been along that S3 road, right? So we continue to move within S3. So, SolidFire, dumping snapshots via S3, fabric pools that Arthur talked about, AltaVault, which has always spoke S3, but now has the ability to tie in SnapMirror streams from traditional NetApp NAS deployments and so on. So, we're going to continue to see development in this space, new use cases, and the idea that's driving this, and Arthur got this, Dave's example, I thought was very good, is where the data lives at any given time can be problematic. There's always some other reason for it to be somewhere else, whether it's to leverage compute capabilities in Amazon or whether it's to make sure it sits closer to the creative studio that's doing the animation for the next part of the movie and so on. So the ability to have the most interoperability between the different service levels, capacity, and performance points, that's all what the data fabric's all about. So StorageGRID Webscale, this is the high-level slide. Then we're going to dive into the architecture and go into a lot of this in more detail. It's a software-defined object store, meaning you can deploy this as software in a VMware environment, an OpenStack environment, coming very soon in Docker containers. It can also be deployed in a purpose-built appliance based on our E-Series product line. We'll talk a little bit more about that. It also can be deployed on non-NetApp storage, under any of those software-defined modes. And it's not an or, meaning as you grow your environment, as your needs change, the namespace made up of this giant StorageGRID environment can be made up of multiple deployment types. I might start a deployment in a data center that has my VMware Center of Excellence. I don't feel a need to deploy appliances there. I'm going to leverage capacity and personnel. I might have a cheap and deep data center somewhere where I don't have a lot of skilled IT. I'm going to rack and stack dense appliances in there to build my capacity. So very, very flexible. And this kind of comes from our history with this product where, when we bought this company, they were largely in healthcare. And the use case in healthcare is pretty unique in a lot of ways. If I'm an IT person in healthcare and you hand me this X-ray image, the chances are, wherever I am, there's some regulatory reason that says I cannot get rid of this image for the life of the patient plus some number of years. So that means for my whole career, if it's a pediatric or something like that. So the ability to have a software environment that can change over time, because think about this, every element of my IT infrastructure is refreshing multiple times before I'm allowed to get rid of this thing. So the ability to live with that constantly and flexibly, that's a key capability of this product. We'll talk about the protocol some more. I'll talk about the geo-redundancy. The real key thing that we're going to talk about is how we can leverage these policies, which you can think of as a built-in service catalog in the product. So, the biggest slide build you will ever see, something like 25 clicks. But we start with, it is a geo-dispersed namespace. It's a global namespace that can span up to 16 data centers around the world, connected via IP. I don't care about the latencies. Certainly will come into play with some of the durability topics that we'll hit on, but for the most part, connecting across oceans and so on, we have lots of deployments doing that. The grid is built up of several node types. So we'll build this out. The first node type is called the admin node, does just what you think something called an admin node should do. Provides the GUI into the environment, manages the audit logs, things like that. No matter how big your environment is, if you're 16 data centers and hundreds of nodes, the requirement is you'll have 2 of these admin nodes. And even if you lose both of them, the grid continues to function without any problems at all. You can just reinitiate them. And one thing I'll point out is object stores and the people that deploy them don't generally care too much about GUIs. These tend to be going into massive environments that already have some kind of orchestration capability anyway. They want RESTful management APIs. That's what they're looking for. So I'll tell you that the GUI delivered by our admin node is actually written using all of the RESTful management APIs to communicate with the grid. So you could do everything that we've delivered in whatever color, shape, and font size you want to using the APIs that we provide that are documented. Then we build out the storage nodes. These are the unit of capacity and performance for the grid. The first thing you'll note is I made an example here where there's 3 nodes in one site, 3 in another, 4 in another. What I'm saying is you don't have to have this perfectly symmetric architecture. This is not a rigid ring architecture. You can grow different sites to be larger or smaller or have different performance characteristics based on what your workload is. Very, very flexible. Very easy to expand, very easy to decommission. No professional services required. It's a click. Then we add our apps. Our apps can speak the industry standard object APIs, Swift and S3. And I said that in the wrong order, S3 and Swift. Because I'll tell you that I don't know about this audience, I do not see a lot of Swift out there. And when I do even see Swift as a deployed object store, I tend to see it speaking S3, not the Swift API. And the reason for that is the whole ISV ecosystem has moved in this the S3 direction. That's where the apps are, that's the API. We do support Swift, however, if you do have some of those. We also have this.
Still supports CDMI, even though nobody uses it, right?
So the question, well, you're mic'd, I don't have to repeat the question. So CDMI is still in the product, it's deprecated. So we're not doing further development on CDMI, CDMI was SNIA Open Object Data Management API, actually superior to S3 and Swift. It's the beta max of object APIs. Right? All right. So we have this interesting thing called the NAS bridge. Now, there's this whole industry out there that you're probably all familiar with called cloud gateways, right? And a cloud gateway typically is some virtual machine or physical machine that presents a file system and then speaks object APIs into a cloud or an on-prem object store. You heard about one just a moment ago. So Alt-to-Vault is a cloud gateway. It's a purpose-built cloud gateway, designed for high performance ingest of backup streams with deduplication, compression, encryption, and so on. This is a little different. The unique capability of this NAS bridge, it's a VM, presents a file system, is that when a file comes into it, then the file goes into the object store, that file becomes an S3 object. It's file to object duality, meaning I can get that file back out again through the NAS bridge. I can also get that file out via an S3 get command. So the idea here is this is one way for you to start moving legacy workloads using NFS or CIFS into the world of object without having to re-ingest as you develop applications that speak object. Okay? So I'll talk a little bit about how we do our reads and writes in this environment. So when you do a put into StorageGRID Webscale, I'm going to immediately make 2 copies of the object, 3 copies of the metadata in our underlying NoSQL database we use to store our metadata. And then I'm going to acknowledge the write. And then, only then, am I going to execute the policies that say, where does this thing need to live and how do I need to protect it? Whether it's erasure coding or replicas and so on. And it's important to say it this way because what that means is, regardless of what your protection scheme is going to be for this object, maybe this thing I just ingested over here, my intention is I'm going to erasure code it across 3 sites. But the performance and time penalty of that erasure coding and dispersing of the fragments is not in that write path, right? So I acknowledge to the application very quickly. That's one of the reasons we can do this multi-site. Now, I am fully consistent across my namespace in read after write. So if I immediately do a read from my app up here, it's going to know it's going to look here, it's going to look in its distributed NoSQL environment and go.
You're not eventually consistent? You're fully consistent at the time of write?
Fully consistent read after write. Yeah, because if I don't find the metadata here, I'm going to go search in the rest of my NoSQL environment, locate if that object exists, and return it. I'm eventually consistent on overwrites. So if I overwrite an object, I might not have the metadata propagated to the site where the read is happening. So in that case, you might be, a second or 2. But I'm fully consistent read after write. So it's kind of cool, right? Nice capability there. So where was I? Let's do the next clip. So policies. This is the service catalog thing. And what this does for StorageGRID is it gives you the ability to think of this thing as something that can obey business rules, not just be this big, cheap bucket of stuff, right? Because typically people think of object storage. I'm kind of insulted by this, but there's flash and there's trash, and I'm the trash, right? So what this does, though, is the policies, and these are object granular, and I'll explain how we do this. I can set rules in my object store that say things like, let's say I'm a service provider, and I'm going to deliver, multiple service levels, the typical thing, gold, silver, bronze, whatever. An object comes into my object store. It has a custom key value pair inserted as part of that S3 put that says service level equals gold. I have a policy that says, if service level is gold, I'm going to make 3 copies, 1 in each data center, so that I have great durability and I have low latency reads for all of those data centers for the first 90 days. But after 90 days, and I'm going to get a local get. After 90 days, I'm going to get rid of a copy, go down to just 2 copies. I might go to erasure code it for the next year. I could even do things like tier it out to a cloud, and I'll explain how we can do that as well. So if you think about what a policy can do, it can manage at any given time where an object lives in locality, what tier of storage it sits on, because these storage nodes could be different performance points, what level of durability we're giving to that object, whether it's replicas or erasure codes or whatever the case may be for recovery. All of that determined by policy. Now, what happens if I create this great policy that says this is how I'm going to treat this thing for 5 years? What are the odds that 2 years later that policy still makes sense for the business? Probably nil, right? We've added new data centers, we've changed regulatory requirements, safe harbor isn't safe harbor anymore, whatever the case may be. Because StorageGRID Webscale stores the metadata in this distributed NoSQL environment, not munging it up with the object, I can change the rule in that policy engine and reevaluate the metadata, and the objects will just move to where they need to be. So all of a sudden, because of safe harbor, I don't want to put that extra copy in New York anymore. Instead, I want to create 1 copy in London, 1 copy in Amsterdam, 1 copy in Munich, right? So I'm going to reevaluate the metadata across that environment, and we can do that at about 7 billion items in a full grid, 7 billion items a day. So it can go very, very quickly, right? This is a way for us to change the business rules. All right. So replication versus erasure coding. So the 2 basic durability choices that you can choose. Replication's pretty obvious, right? I can choose to put copies anywhere I want. The way we determine where something lands is we create these logical pools of those storage nodes. Like there might be a pool called the New York pool, there might be a pool called London, a pool called Amsterdam. Similarly, there could be a pool called SG5660 appliances, which is one of our deployment methods, and maybe there's some of those across all of these. So a node can belong to more than one pool. The thing you need to remember about a pool is that's the target of anything you do with a policy. So for erasure coding, all we do is say, here's your encoding scheme, here's your pool. So in this example, I have 3 data centers. I'm probably going to do something like a 6+3 or a 6 of 9 EC code, right? But I can support any number of Reed-Solomon EC distributions. It doesn't matter, right? I mean, what matters is you understand the capabilities of that distribution so that you're actually building something that does what you want to do from a recovery standpoint. Everybody understand geodispersed EC? How that works? All right. That's probably the first time in a room I've ever asked that, and everybody nodded their head. I should be very worried right now. All right. So I'm going to take an object. It's a media object. It's a good example. Big thing. I'm going to do a 6 of 9. So that means I'm going to chunk that thing up into 6 pieces. I'm going to add 3 pieces of parity data, and I'm going to put 3 in each, right? Now, something horribly bad happens. I lose a data center. I can now lose any data center, and I can get this object back by getting any 6 pieces, right? That's the benefit of EC. Now, the sharp edge of geodispersed EC is this sure looks a whole lot like doing RAID over geography, right? And that's not a really good idea. So what we do is we do something kind of interesting here. We've actually renamed it now, finally. It had a horrible name in the past. It's now called layered EC. It used to be called hierarchical EC. But the idea is, in our storage node itself, in that, and this applies to the SG5600 series appliances, we do node level EC in that appliance using something called DDP, or dynamic disk pools. It's essentially a 8+2 striped node level EC, right? So roughly 5x faster than RAID recovery. Almost no impact to performance. I said no impact in performance to someone the other day, and that's not true.
That was me.
Yeah. So you're absolutely right, Howard. There is a minimal impact to performance. But what happens, though? Why do we do this? 90+% of any kind of failures you're going to have are going to be those, I've lost a storage device or 2 or 3. So I'm going to handle those, repair them in the appliance. Out of my network bandwidth, out of my compute. I'm not going to be doing these reconstructions over GOEC for standard failure situations. The only time I'm going to be doing that reconstruction over GOEC is something horrible happened, right? Now, a couple interesting things about the way we do this GOEC. Large objects, typically what you do GOEC with. We don't do what's common in the industry. We don't do essentially an all or nothing transform, meaning if you request this object, I don't have to put the whole thing together before I give you the first byte. I can start sending you chunks of this object, streaming them to you, and building the thing behind it. I will even repair inline if I hit a bad block. I'll repair it from whatever durability data I have, whether it's a replica, whether it's a DDP, whether it's remote EC, right? Now, what's really kind of magical is S3 has this capability called range reads or byte range reads or offset reads, depends on who you're talking to. But this is the idea that, similar to in the old days, you could do a single file restore on a tape device where you kind of knew where to move the tape drive to and pull stuff out. We can do byte range reads on geo-dispersed E-seed large objects. That's kind of magic. And again, it comes back to the fact that we're storing the metadata separately from the object itself so we know where to go. And because we don't have to do the all or nothing transform, we don't have to build this whole thing. So this makes the product very suitable in these environments where we're dealing with extremely big things like geoseismic, in the energy space, and media, right? All right, so deployment. Let's talk a little bit about how we build these things out. I'd clicked a couple new nodes added, right? Very simple to provision, right? It literally is a click on your admin node to provision new storage nodes. You add them to a pool, they become load balanced into that pool. right? Another box appeared, this gray thing. This is an optional node type. It's called the archive node. Arthur talked a little bit about this. This is our ability to tier outside of the StorageGRID environment to another S3 target. So think of it as federating grids. In this case, I could tier this out to Amazon S3, have a bucket policy in Amazon that sends something off to Glacier, and it's just part of my policy. So policy might be, hey, 3 copies for the first 90 days, GOEC for the next year, then, hey, I don't even want it anymore, send it off to Amazon. We can also send it off to tape as an active tier. In this case, we use TSM middleware in order to accomplish that. Now, how do you deploy this? We talked a little bit about software defined. We can deploy this in a VMware environment. We can deploy this in an OpenStack KVM environment. In both of these environments, we're actually using Docker now. What we're doing, though, is we have the Docker containers deployed in a Debian guest that is then virtualized in either VMware or KVM under OpenStack. And then, like I said, coming soon is the ability to do this without a hypervisor, just with Docker containers. So think orchestration by provisioning Kubernetes and so on. So even more flexibility there. And then these 2 little tiny things, I probably could have blown them up a bit. These are our appliances. They come in a 4U60 drive format and a 2U12 drive format. And they look like, I was trying to get one to bring in here. I couldn't find one. Most of them are in RTP, Vancouver, and Wichita, unfortunately not Sunnyvale. When you flip it around, it looks like a standard E-Series box. It's got 2 controllers on it. One controller is running Centricity, which does the DDP for us and the enclosure services and so on for the box. The other controller is a slightly beefier controller, and it's running StorageGRID in bare metal. And it comes pre-installed with something we call a PGE, pre-grid environment. So racking and stacking these things, they're identified quickly, they provision themselves with a very simple process, and you're up and running. And again, you can mix and match these things where you need to have them. The typical customer behavior I see is people tend to do sandboxes and proof of concepts and things with software defined. But when they start rolling out at scale, it's significantly easier to rack and stack 60 drive units of storage, right? So these come with 10 or 6 terabyte nearline SAS drives. We also just added a capability to deploy FIPS drives, 140-2 encrypted drives in there as well. I didn't mention security. You can do encryption without having encrypted drives. So we can encrypt the entire grid. We also, all the communications are TLS 1.2 with your choice of ciphers for inter-node communication. So everything's encrypted that way as well. Compression is also an option. We can turn on compression as a grid-wide setting. And you also have the ability to encrypt via an individual S3 put, right? So, any questions on that before we clear as mud? I feel like I'm talking really fast. So this is an example. If we look at kind of the first verticals that I put up at the beginning where I said data archive, media, and whatever I had for born in the cloud, like web-based applications. These are examples of partners that we're working with now. And I can tell you, the slide is already out of date. I'm aware of, so Veritas, I don't see up there. Veritas now introduced a new version of their S3 tiering out of Enterprise Vault. So we're all done with that as well. So we support all those common backup applications. You can use straight S3 or you can work with the AltaVault, either way. And sometimes it actually makes a lot of sense to not use the backup vendor's native S3 capability and to use something like the AltaVault because of the additional storage efficiencies that we're getting out of the AltaVault. A lot of the in the S3s are not deduplicated, so there's a significant storage expansion there. So a couple of examples. NetApp. We used to say, eat your own dog food. I got lectured, it's drink our own champagne, right? So our IT organization replaced the last of the tape with AltaVault and StorageGRID Webscale. And they're at 2 sites right now. They're adding a 3rd site to the grid, I think this quarter. Now, we also use StorageGRID internally as the testing backend for any of the other stuff that Arthur was talking about with the data fabric, right? Unless it's specifically calling out region-specific commands in AWS, we are so S3 compliant that it just makes more sense economically to do all of that QA in what we call our customer zero environment, where we run StorageGRID kind of as a service for our dev team. ASC, this is an interesting one because this talks to that data. If you're on-prem, you're not necessarily going to stay on-prem. I mean, the assumption we made when we got into this StorageGRID Webscale thing was this is an on-prem object store because some people don't want to be in the cloud. Well, I think that assumption is pretty flawed. I think what really we're seeing is any object stores of size have needs in both places. So in the media world, for example, a company like Disney is not going to put their media crown jewels in someone else's cloud, right? That's Cinderella and Moana and all. I'm keeping that, right? But at the same time, when Apple introduces the iPhone 10, and now they have to transcode all of their video assets to meet those new codecs for the new devices, they don't have the ability to do that quickly, right? So what they're going to do is they're going to send it up into the Amazon cloud, use Amazon's elastic transcoding service, and build the new versions of those things. So this company, ASE, is a service provider in Asia, based out of Australia. They're a service provider specifically to media, and they provide media asset management and things like transcoding services. And this is NetApp private storage with StorageGRID. They're running StorageGRID on their hardware in a direct connection to AWS and utilizing AWS's transcoding services, and actually getting 60% faster transcoding performance against StorageGRID than they were against native S3 without the S3 costs. So I see this kind of use case popping up in other verticals, in pharma with the need to do elastic MapReduce in the cloud and Elasticsearch and so on. So I think we're going to continue to see these workflows.
So it's StorageGRID running on E-Series and a NetApp private storage environment.
Yep.
Okay. It's not like ONTAP behind StorageGRID or something like that.
It could be. And in fact, these guys have some of this grid is running on spare capacity on their FAS and virtualized, and some of this grid is running on E-Series appliances as they've been expanding it. But it's all, the point of it is it's all theirs.
Yeah.
Yep.
Whoa.
So last one.
Does it sound like a data fabric yet?
Yeah.
And we just see more and more of these things coming, and you're going to see interesting things with us, just as Arthur was alluding to all the things that we're doing with AWS in the ONTAP world. Similarly, there's lots of things going on in the object storage world as well.
Dave, you made it from spiderweb to gauze.
Nah.
All right. Advanced Unibyte's a fairly large service provider in EMEA, and they're providing backup as a service using AltaVault, using StorageGRID. They're also providing S3 as a service as well. We have quite a few of these service providers. They don't have to compete with Amazon on price because they tend to be offering more of a white glove service, or they have vertical specific capabilities like ASE. And we're seeing these pop up all over the place, and StorageGRID is just a really nice fit for them. So that was what I had.
Very good.
So again, we have a release that's imminent, and I'd be happy to take any questions.
Since it's come up on Twitter a couple of times, you guys have CIFs up there, right?
Yep.
That denotes SMB1. Do you guys support SMB2 or 3?
SMB2, SMB2 with the NAS gateway right now.
Okay.
NFS 3 and NFS 4 right now on the NAS gateway, but NFS 4 is a new thing. Yeah. And we also, this isn't the only NAS gateway, right? So us having one is not precluding us from partnering with others, right? So there's all these NAS gateways have different things that they do well. And my goal has always been, if someone speaks S3, I want them speaking it to me. So
I know that even NetApp has OEM'd, or in some cases partnered with SoftNAS to go
Yep.
in front of StorageGRID? So any of the service providers using that? And I know they got a big Amazon presence.
I'm not aware of any large softNAS deployments now. They are a qualified partner with us for StorageGRID. So is people like Cetera, Infinity, Citrix ShareFile, which is not quite a NAS gateway, but more file sync and share and so on. And I think there'll probably be more coming